Hello and welcome back. In this video we are going to continue where we left off and look at configuring and finishing the Layer 3 VPN configuration with BGP as a CE to PE routing protocol. So up to present we've configured MPLS, we've configured the core BGP neighborships for AS65991, and we've also configured the VRFs on the PEs and put the correct interfaces into the correct VRF depending on which customer. So what we need to do now is we'll start here and work our way across, but we need to configure BGP between the customer and us, and then once we've done that we can start advertising routes from the customer into our network, and we can start seeing those appear for the other sites for the same customers. So starting on PE1, what we need to do is go into router BGP 65991. It's a little bit different here because we're using VRFs, so we'll have to do address family IPv4 VRF customer A. So once we're in this address family, it's just like a normal BGP neighborship. So neighbor 80.1.17.2, which is the IP address of CE cust A1. So we'll set the remote AS to 65,001. So this is an eBGP relationship. And then we'll come on to the CE router. And we'll do a show IP interface brief because I believe, yes, the interfaces are shut down. So interface gig00, no shutdown. And one thing to double check is that we definitely have communication with, when we do, with the PE router. So on here, one thing I want to do first of all is configure a loopback, so that we can advertise that to the PE, and we can verify that that shows up in the VPN v4 table, working across the network down to this other site for customer A, and making sure that once we're all configured with BGP that the routes are appearing within the customer routing tables. So we'll configure an IP address of 10.1.1.1 with a /32 mask, and then we'll do the router BGP 65,001. We'll set the BGP router ID, we'll set that to the 80 address just so it's a bit easier to recognize. And then we'll set the neighbor as 80.1.17.1. We'll set the remote AS to 65,991. We'll also do a network command for 10.1.1.1 with the mask 255.255.255.255, so that gets advertised into BGP. So we can see that has come up. And if we come back onto PE1, we can see that's come up as well, and it's come up within the VRF customer A. We can verify that by doing a show BGP. In fact, if we do a show BGP, show IP BGP summary, we won't see it in here because this is non-VRF specific. So if we do show BGP for VRF cust A all summary, we will see there is this router with the neighborship, and we can also see that we have received one prefix. We can verify that by doing a show BGP VPN v4 unicast all. We can see there that that is the route that we advertised. We can see the next hop. We can also see that the route distinguisher has been set properly, and we can see that the VRF is correct. In theory, we should also be able to see this route up at P1. So if we do a show BGP VPN v4 unicast all, we can see that route's up here as well. The next hop is correct. That's P1. So if we now do the same configuration for this router down here on PE2, we should have our first customer set up and working with layer 3 VPNs. So come on to PE2, global configuration mode, router BGP 65991, and again address family IPv4 for VRF cost A, and we'll do neighbor 80.1.19.2.255. Oop. Thinking I'm typing an IP address. Remote AS 65002. And while we're here, we may as well do the customer B. Their AS is 65003, and instead of 19, it's 20. So coming down to this router, I'll again do show IP interface brief, and that is administrative down. I've just noticed that IP address is wrong, so we'll do IP address 80.1.19.2 instead of 81. We'll do a no shut, and then we'll quickly verify that we can reach the PE. We can, that's a good sign. And again, we don't have a loop back, so we'll do IP address 10.2.2.2 with a /32 mask. Right, and then we'll do what we did at site 1. We'll do a normal BGP configuration. Set the BGP router ID to this. We'll set neighbor 80. Actually, that is the incorrect address. Set it like that. We'll do neighbor 80.1.19.1. Remote AS is 65991. And then again, we'll do the network command for 10.2.2.2 with a mask 255.255.255.255. So again, come on to P2. We can see that the neighbor has come up within the VRF. We can verify by doing a show BGP VRF cost A all summary. You can see there we haven't received a route yet. There we go, we've received that route. So again, we should be able to do show BGP VPN v4 unicast all. And so in here we see the route that's come from site 2, and we also see the route here that's come from site 1, and we can see the correct next hop for each of them. So in theory, we can come up to customer A site 1, and in our routing table we've got a BGP route here for 10.2.2.2, which is the loopback on site 2, and the next hop for that is the PE router. So what we should be able to do is do a ping to that, making sure that we source it from our loopback, and we can see that that is succeeding. We can also do a trace route, do that a little bit differently with the extended version, otherwise we can't specify a source. Oop, that's the target. The source is 10.1.1.1, and skip through this, and we should see that, yep, that is going across our MPLS network and it is reaching site 2. So that is layer 3 VPN configured and working for customer A. So we can replicate the same thing we've already configured for customer B on PE2. So if we come to CE customer B site 2 and do a do show IP interface brief, and what we'll do on here, just to show that we can use the same IP addresses within the customers, what we'll do is we will configure the loopback 0, and what we'll do is we'll configure the same IP address as we configured on customer A site 2, just to prove that the routes are contained within the VRFs and we can't communicate between customers. So 10.1.1.1, in fact, because this is site 2, we'll do 10.2.2.2. We'll set a /32 mask. Help if I add the address command. And the interface on here is gig00. Make sure we no shut that, and then just to make sure that everything's working properly, we'll make sure that we can ping the PE. We can. So we'll scoot this over a little bit. Router BGP 65003. We'll set the neighbour to 80.1.20.1. Set the remote AS to 65.991. And we'll set the network to 10.2.2.2 with a /32 mask. And we can see that's already come up there. So we'll verify that on PE2 by changing this command to look at customer B VRF, and again we can see we've got a prefix from them. If we look at the VPN v4 table, we can see that this route it's exactly the same, but we can see that it's got a different route distinguisher and it's been pulled in via a different VRF. So we can customers can be using the exact same IP address or the exact same IP space, and they are still being distinguished. So if we configure PE3 the exact same, router BGP 65991, address family IPv4 for VRF customer B, sorry, not A. And then what are we over here? 80.1.18. 80.1.18.2. The remote AS is 65,004. Yep. And then again, come on to the CE for that site. Do show IP interface brief. So in G00, do a no shut. Do ping, make sure we can communicate with the PE. .1. And we can. We also need to create a loopback. What we'll do on here, we'll make it different, just so that we can prove that IP address 10.3. We'll do a /32 mask. Okay, so router BGP 65,004, BGP router ID, set that as the router ID, and set the neighbour as .1, remote AS 65.991, and we'll set the network to 10, we'll add the network 10.3.3.3 with a mask of 255. There we go. Oh, I have configured do show run section router BGP. exit no BGP, no router BGP, sorry. .5504, just router BGP 65004, and then we'll just pull this same configuration in. There we go, sorry about that. And that should come up fine this time. There we go. So on PE3 we should have the same coming up in the VRF. And again, if we do a show BGP for VRF customer B, all summary, again we see the router there, and we see that we've received a prefix from them. So if we do a show BGP VPN v4 unicast all, we can see that for the VRF for customer B, we can see that both routes are in here. We've got the correct next hops. So again, if we come down to here, do a show IP route, again we've got a BGP route for 10222, and if we come in here and do a show IP route, we've got a BGP route for 10333. So we can do a ping to 10333 and source that from loopback 0, and that's working fine. And again we can do a trace route to 10333. Oh, jump the gun a bit. 10333 from 10222. Again, we can see that that's going over the MPLS network, and we can still, on the CEs for customer A, we can still communicate on there as well. So if we come onto P1 and issue that VPN v4 unicast all command again, we can see all of the routes for all of the VRFs in here. At this point we can come onto any of the customers and configure say another loopback IP address 10.9.9.9 for example. Oop, got an extra dot in there, and then route at BGP, and that'll be 65,001, and then add that in as a network. You could also do a redistribute connected command, but in this case, in fact no, we'll do a redistribute connected. So back on P1 after a little while, again, yep, we see the 10.9.9.9 network, and because we did the redistribute connected, we can also see the 80.1.17.0 network, which is the link net between CE customer A site 1 and the PE. So if we come back onto here and do a show IP route, we can see that BGP route for the link net has appeared in here, and we can also see that 10.9.9.9 has appeared in here as well. So we can do 10.9.9.9, source that from our loopback, and that will also succeed. So we have now got a fully working MPLS L3VPN network, serving 2 customers between 4 different sites in theory, and everything's working with BGP. So in the next video we'll look at using OSPF for the P to C routing and how that differs, because we'll have to do some redistribution, because obviously we've got to get those OSPF routes into BGP, and then the BGP routes out of BGP and back into OSPF on the PEs. So hopefully see you there.